Hello friends, here the computer network class. In previous class we have learned sliding window, go back and RQ protocol. Now here the second protocol of sliding window is selective repeat ARQ. There is one drawback in go back and RQ protocol which is solved by selective repeat ARQ. Now here in selective repeat ARQ, and window size of transmitter side is n, and here the receiver window size is also n. In previous go back and RQ, the receiver's window size is 1, but here in selective repeat ARQ, the receiver's window size is n and the transmitter's window size is n. Must remember, total number of sequence is here 2n. In total sequence number in go back and RQ is n from 0 to n. Now here selective repeat ARQ, total sequence number is 2n. Window size of transmitter and window size of receiver end. Here the total sequence number is transmitting window size and the receiver's receiving window size. Here to represent a sequence number, frame numbers mod with 2n. Okay. Now here the case number 1 is that if there is a 4 frames, here the window size of the transmitter size is 4. We take it 4. ठीक है, suppose किया है. So the sequence number start from 0, 1, 2, 3, mod with 2n. Here the window size is 4 and the receiver's window size is also 4. So we take here mod with 8. If we take a mod with 8, then 0, mod with 0, 1, 2, 3. Okay. Here when the transmitter transmit frames of 4 window size, here the continuous transmit of 4 frames. Here the receiver receives frames F0, F1, F2, F3. Here there is a 4 frame. Size of buffer size is 4. So if the receiver receives F1, F0 receiver receives F0, then it take it buffer. If the receiver side is busy in another processor, so at that time the receiver store the coming frame to its buffer, because its buffer size is 4. So the receiver can store the coming frames in its buffer. So it stored F0, then F1, then F2, F3. And when the processor become idle, then the receiver ends will process it. But in go back and RQ, there is only one window size, means that there is no buffer. So at a time, so when the frame comes, receiver end process it, and another frame comes and receiver process it. These frames are coming and it processed by receiver end. But here if the processor are busy, the frames can be buffered at buffer memory. Okay, and then send acknowledgement. Here if F0 is processed, then the receiver end send acknowledgement to the transmitter. The same happens if F1 processed, then send acknowledgement. After getting acknowledgement, if F0 is acknowledgement received, then the transmitter end load F4 in its window and transmitted with the sequence number 4. Must remember, here the transmitter already transmit to sequence number up to 3. Now it transfer sequence number 4. After getting the acknowledgement of F1, it send frame 5, sequence number 5, then 6, then 7 after getting acknowledgement. Okay, and same thing after F4, F5, F6, F7, receiver received F4, F5, F6 and send the acknowledgement to the transmitter, and transmitter again sent after getting A4's acknowledgement, transmitter sent next frame. So transmitter already transferred frame up to sequence number 7. Now here if we take a mod 7 with 8, because the window size is 8, okay, 2n. So taking mod with 7, the value comes 7. Now here the frame is 8. When the frame is 8 and getting mod with 8, we get 0. So the sequence number is 0 here. Now the A4 acknowledgement comes, then the transmitter send 8th frame with sequence number 0. Now A5 acknowledgement come, A4's acknowledgement, A5's acknowledgement come. Receiver loads F3 frame, F9 frame, 9 mod with 8, 9 mod with 8, mod get sequence number 1. So here the F9 frame will be transmitted with the frame 9 and sequence number 1. Now in case 2, there are 4 frames transmitted one by one, continuous manner. If the receiver here, what happens if the F0 frame is lost? F0 frame lost. Then after that receiver received F1 frame. Here the receiver know that F0 frame is lost. F0 frame is lost. After that receiver received F1 frame. Now here receiver accept F1 frame and store it into its buffer, because the buffer size is 4. So here the receiver received F1 in its buffer and wait for F0, because the receiver have buffer, so it can store F1s in buffer and send acknowledgement to the transmitter. And again F2 comes, then receiver store buffer, F2 in buffer, and F3 comes, then store in buffer. Here when F1 received by the receiver, then it send acknowledgement to the transmitter. And when the transmitter get acknowledgement A1, the transmitter conclude that why S1? Where is the A0 acknowledgement? If the A0 acknowledgement is not come here, so the transmitter conclude that might be F0 frame might be lost. So it here when F0 lost, F1 received by the receiver, F1 received receiver received F1 in buffer, F2 in buffer, and F3 in buffer. When the timeout, when the F1's acknowledgement won't come, till its timeout, when here after when A0 acknowledgement won't come, the transmitter conclude that A0 acknowledgement won't come till now. So maybe F0 acknowledgement get lost. F0 frame might be lost. So after time over, transmitter send F0 acknowledgement, F0 frame to the receiver end. After getting the F0 frame, now the receiver will process F0, F1, F2 and F3. After getting F0 frame, the receiver processed F0, F1, F2 and F3. F2, F1, F2, F3 are already stored in its buffer. After getting F0, it processed all frames, all 4 frames. Then after receiving F0 frames, it sent acknowledgement. It's send acknowledgement. Okay, A0 received. If A0 received and A0 received, acknowledgement get by the transmitter. Now the transmitter send next frame. Next frame, which one is next frame? A1, A2, A3 already sent by the transmitter. Now next frame is F4. F4 frame sent by the transmitter end. Now if the transmitter get the acknowledgement of A1, then it send the frame F4. After getting acknowledgement of A2, transmitter send A6 frame. The same minus happens. The same thing happens next to the H frame and get acknowledgement and send the next frame. Now the case 3, here the 4 frames transfer continuous, and the F0 to F3, all frames received by the receiver end and processed and send acknowledgement to the transmitter. But if all acknowledgements lost, then after timeout, if the A0 the acknowledgement won't come, transmitter transmit F0 again, transmitter transmit F1 again, F2 again and F3 again. Here F0, F1, F2 and F3 frames are discarded by transmitter receiver end, because the receiver already received F0 to F3 frames already received, so it discarded and send acknowledgement to the transmitter end that A0 already received. A0, A1, A2, A3 acknowledgements, send acknowledgement to the transmitter. After getting acknowledgement of A0, transmitter received A0 acknowledgement and send next frame which is A4. So frame 4, F4. Then after getting acknowledgement A1, transmitter send F5 frames. Means that here the cumulative or combined acknowledgement not here. Here the combined acknowledgement is not here. If the one frame is discarded, then there is a one acknowledgement, and for F1 here is a one acknowledgement, means each acknowledgement define 1 frames. But in previous, go back and argue, there is a if all 3 acknowledgements are lost and A3 acknowledgements received, then the transmitter conclude that all previous 3 frames are already received by that receiver, because in go back and argue the frame size is 1, so the receivers only process single process. If the A3 acknowledgements come here, now all previous frames are already received and processed. But here because of the buffer size is 4, if the A3 acknowledgements come, means that only A3 is processed, and if A0 acknowledgements come, the transmitter conclude A0's acknowledgement comes, means that A0 is processed. Here the one acknowledgement gives the idea of only 1 frames, not the combined state. Okay. Transmitter transmit n frames without any acknowledgement. Here transmitter transmit n frames first without any acknowledgement in first case. Here the receiver transmit individual acknowledgement for every successful received frame. We taught it that here the receiver transmit a single acknowledgement for single frames, not combined acknowledgement here. Here the cumulative acknowledgement does not exist. In selected repeat hierarchy, combined acknowledgement won't happen. Here, when the transmitter get timeout, receiver acknowledgements to transmit that particular frame only. When here the timeout happens, here the when timeout happens, the transmitter send only that frame that timeout occur. Here the transmitter transmit only single frames, that frames timeout occur. Now here the conclusion of all three protocols. Here the sliding window protocol, the sequence, the total number of sequences n. Now then go back and argue, total sequence number is n plus 1, and the transmitter window size and the receiver's window size. In selective repeat ARQ, total sequence number is n plus n, means 2n. Here the number of bits required to represent the sequence number. Here is 2k for represent the sequence number of sliding window 2k, the formula. In go back and ARQ, 2k minus 1. In selective repeat ARQ, 2k minus 1. Means that now here the go back and ARQ. Go back and ARQ is preferred when the channel has less error rate. Because in go back and ARQ, if the frame is lost, if one frame is lost, then the transmitter have to send all previous frames. If the transmitter send frames and the receiver received last frame but lost the initial frames, then the transmitter have to send all next frames again, because the receiver want to receive the received frame in buffer. But here in selective repeat ARQ, the receiver received upcoming frames in buffer and send acknowledgement of that frames. So here in selective repeat, the transmitter send the frames that which here the receiver received that frames only which have acknowledgement weren't received. But in go back and ARQ, it sends all next frames or all previous frames, after which timeout happens. In selective repeat prefer when channel is more error rate, then selective repeat ARQ is preferred, because here the only single frames acknowledgement is to be sent, because proper buffer utilization. Now here the bit error rate. Bit error is number of bits error per unit time. Per unit time में कितने buffer कितने bit error आ रही है. Bit error ratio, probability that bit is corrupted. The formula is PV is the bit error probability and the frame length. Here, what is the probability of the frames that has been received by the receiver does not contain any error is 1. Here the error of probability, so 1 minus b to the power l. So the probability of frames that does not contain any error.